Okay, this is number 10 on 13.3. We're asked to find the unit tangent and principal unit normal vector of r of t. So first off, let's start by finding r prime. So r prime of t is equal to t squared I minus radical 2 tj minus k. And I need the magnitude of r prime of t as well. So the magnitude of r prime of t is going to be given by the square root of t to the fourth, this guy squared, plus this guy squared, which would be plus 2t squared plus 1. And to make our lives much easier, let's simplify this as the square root of t squared plus 1 quantity squared, which is just t squared plus 1. So that the principal unit tangent vector t of t, let's say, is equal to 1 divided by t squared plus 1 times quantity t squared I minus square root of 2 tj minus k. And t of 1 then is 1/2 I times the quantity, 1/2 times the quantity I minus radical 2j minus k. Okay, so now we need to find n of 1. To do that, first we need to find n of t. So that means I have to take the derivative of t to get started on that, because n of t is t prime divided by magnitude of t prime. Now, t of t is a scalar function times a vector function. So we're going to use the product rule to find t prime. So t prime of t is going to be, I'm going to take the derivative of the first, and that turns out to be negative 2t over t squared plus 1 quantity squared. You can verify that. Okay, so the derivative of the first times the second plus the first, 1 over t squared plus 1 times the derivative of the second, which is just 2ti minus root 2j. Now at this point, since we're just looking for n of 1, we can go ahead and find t prime of 1 and then use that result to find n of 1. So t prime of 1 is going to be, well, if you stick a 1 in here and here, you get negative 2/4, which is negative 1/2. Stick a 1 in here and here, and you get just I minus root 2j minus k. And then here you get, you get plus 1/2. So plus 1/2 for this guy, and then 2i minus radical 2j. And then if we factor out 1/2, that leaves me with negative I, all these change signs, plus radical 2j plus k. And may not close that off. Okay, and then I get plus 2i minus radical 2j. And if you combine like terms, you get 1/2. Okay, negative I plus 2i. These guys cancel out. And I get, I guess, I plus k in brackets. And then if you remember, n of 1 is just t prime of 1 divided by the magnitude of t prime of 1. And okay, so if you think about it, the magnitude of t prime is just going to be 1/2 times the square root of 1 squared plus 1 squared, or just square root of 2 on the bottom. And then on top we've got t prime of 1, which is 1/2 I plus k in brackets. So the 1/2s cancel, and you're left with 1 over root 2 times I plus k for n of 1. So if you got t of 1 as this guy, 1/2 I minus radical 2j minus k, and that 1/2 is on the outside times the entire vector. You've got n of 1 as radical 2 over 2 times I plus k, and it turns out that the binormal vector, it does turn out to be a unit binormal vector, by the way, it's 1 unit long. B of 1 will be the cross product of t of 1 and n of 1. And it's true also that if you want to take a cross product, if you have a cross product of a constant times a vector, so for instance, let's say you have a vector c u cross kv, and where c and k are constants, it is true you can take the c, the scalar multiples, outside and then just take the cross product of u and v, which is what we're going to do here. So to set up the cross product, I'm going to do this. The usual I, well, actually let me make a little more room here. The usual I, j, k across the top. Out front, I'm going to put the constants, the 1/2 and the radical 2 over 2, which will make, if you multiply them together, radical 2 over 4, but I'll show that in a little bit later. So there we go. So there's the constants out front, and then the components of t across the middle, t of 1, so 1 negative rad 2 minus 1, and then the components of n of 1 would be 1, 0, 1. 1, 0, 1. Okay. Let me adjust. Okay, and then if we take this cross product, so okay, on the outside, like I said, we'll have radical 2 over 4. The inside, so big bracket, inside, cross out this column and take the determinant of the remaining 2 by 2 matrix after you cross out that column, which gives you just negative rad 2 minus 0, so just negative rad 2i. By definition, there's a minus here. Cross out middle column and then take the determinant of the remaining numbers. 1, it would be minus negative 1. So that'll be a 2 in here, but then a minus 2 times I. And then plus, okay, cross out the last column. It'll be a 0 minus a negative radical 2. 0 minus a negative rad 2. Let me move this over because I just went outside the video screen. There we go. Now I think you can see it. And then that's times k. So after we clean that up, it becomes radical 2 over 4 times the vector negative radical 2i. Well, this will be minus 2, and I should have written j here, of course. j, and then plus radical 2 k. Clean it up, clean up any mistakes, and there you go. Okay, I've plotted, using a program called Autograph, I've plotted the curve given by r of t and the three vectors that you just got done finding when t, the parameter, is equal to 1. The unit tangent vector, t of t, is given by the vector in blue. The principal unit normal vector in green, and the unit binormal vector in yellow, often called the vector b. So let me zoom in on this and show you exactly what it is you're seeing. This program plots vectors with the arrow in the middle and makes boxes out of the endpoints. And I plotted each of these vectors at the point on the curve. This point right here is the point that you get on the curve when t equals 1. And I've placed the tail of each of these vectors, t, n, and b, at that point. And you can see that t in blue here certainly looks like it must be tangent, and it looks like it's probably 1 unit long based on the scaling I've used. It is the unit tangent vector. The vector in green is orthogonal to the vector in blue, as it should be, and it's pointing in the direction that it looks like the curve is bending. If you plot this curve, its orientation goes, if you look at the cursor, from this point along this direction. And so it certainly looks like the vector in green, the principal unit normal vector, is pointing in the direction the curve is bending, as it should. And then, of course, the vector in yellow, which is formed by the cross product of t and n, is orthogonal to both. We often call that vector b, and so we've created a whole new frame of reference called the t-n-b frame. Why do I say that? Why is it called a whole new frame of reference? Well, imagine you're piloting a spacecraft and you're traveling along this curve, or an aircraft, or whatever. Then you could use the TNB frame in an analogous way to how you would use the vectors I, J, and K to plot a course. So there you go.